2 3 days back, which was very important actually, related with this landscape and linkage of national and international quality infrastructure. As we are all aware, the SDGs or the groups which have already been formed at the international level all are working very seriously about the national and international infrastructure strengthening. Due to some problems, our expert, Dr. Sanjay Yadav, is not able to participate today. So we have requested our professor, Dr. D.K. Trivedi, who is a professor in the Indian Institute of Legal Metrology, Ranchi. I have requested and he is kind enough to accept our request and share his presentation on a very short call, maybe just few hours back. And we are thankful to you, sir, for accepting our request. And as we are all aware, you are telling us about the testing and the calibration of non-automatic weighing instrument. One part was over few months back and the second part was pending. So I would like to request Professor Trivedi how we used to calibrate and test the non-automatic weighing instrument. He kindly let us know and explain, which will be very important for all the participants, and the video as well as the presentation will be available in the public domain after the lecture. Sir, thank you very much. As we are all aware, he's a professor, PhD in physics, and having a lot of teaching and the research experience, not only in the engineering college, but at the ILM Ranchi. He's one of the, he's the asset of the legal metrology organization, who is, and the legal metrology see towards him looks towards him in a better way, and how he can help to the legal metrology society. Over to you, sir, please.
Okay, thank you, sir. Thank you, sir. Thank you very much to have your kind words. Today, really, I am very much thankful to our respected director, sir, to give the such opportunity to share the knowledge, experience, especially on weighing instrument. Really, with the help of this presentation, I would like to trace a path to reach the each corner of the testings of the instrument. Really, this presentation is not limited only for the non-automatic weighing instrument, but for all weighing instrument, because maximum things are very much common, because these are equipped with the electronic components. So number of tests, number of requirements are common, whether it is weighing instrument, non-automatic or automatic. Whether we are talking about the automatic railway bridge, discontinuous totalizer, gravimetric, or others catch weighing like that. So number of things are common. And with this presentation, I would make a connection that how we have to start the testing. Prior to that, a simple introduction on my presentation with kind permission of our director, sir. I would like to share my presentation. And
please, sir, please continue.
Okay. Yes, please, slides are visible.
Yes, sir.
Okay.
Very well.
Please. Under this presentation, simple, because prior to few months, I have discussed on the metrological requirements of the weighing instrument. Just a look on that, and after that, directly I will come the requirements of the testing, whether for the type approval or initial verification or subsequent verification. Definitely, we will see a number of things in this chain, because this presentation is basically based on the OIML recommendation R76. When we are talking about the OIML recommendations, especially on weighing instrument or measuring instrument, really 4 core parts are there. That 4 parts, namely terminology. Every recommendation has the terminology, so that we can't define the term as per own. That terms definitions are derived from VIM, means International Vocabulary of Metrology, or VIML, International Vocabulary of Terms in Legal Metrology, or OIML certificate system. So this is common in all recommendations. Now, next one is metallurgical and technical characteristics. This is one of the core part of recommendation. What things covers under the metallurgical characteristics? Like capacity, like scale interval, like indications, all those things, minimum capacity, maximum capacity, these comes under the requirements of the metallurgical and technical requirements, markings, etc. So now this provides the testing procedure about the metallurgical characteristics. Now next one is most important core part, metallurgical and technical requirements. Whatever we are doing during the verification, whether related to the model approval or initial verification, we have to check whether the instrument confirms the requirements or not. What kinds of requirements? Basic is accuracy class, maximum permissible error, scale interval. These are the core part, whether that instrument meets the requirement or not. Now, last one is control. Every recommendation provides the metallurgical control on that. In India, we see that this control is with central government as well as state government or UTs. Regarding the type approval, type evaluation is related with the central government. Now, enforcement part under the control is initial verification, subsequent verification, and service inspection. So this is not only for non-automatic. This is for all, whether you see the recommendation related to the railway bridge or related to or any other measuring instruments like fuel dispenser, etc. So on 4 core parts, all the recommendation is covered. Now, if we see under the legal metrology, not only non-automatic, for entire metrology, the global acceptance is divided in 6 parts. It started from the standard units, whether we are talking about the weighing or measuring instruments, or we are talking about the packaged commodity. Standard unit is the most important key part of the legal metrology. Now, next one is every country has to maintain that standard units in form of the physical representation. Now, third one is by maintaining the traceability, hierarchy. Next one, their requirements related to the technical and metallurgical. Then control. Then authority responsible for legal metrology. For what? Fees, offenses, and penalties. When we are talking about the control on legal metrology, broadly we can divide in 2 parts. Control on weight or measure, means including weighing and measuring instruments, and control on package commodity. When we are talking the control on weight or measure, means started from pattern evaluation, initial verification, subsequent and in service. Control on manufacturer means manufacturing license based on the model approval certificate where is applicable, importer, repairer, and sale of weight and measure. Similarly, control on package commodity, labeling requirements means declaration to be appear on every package. Prevention of deceptive packing, inspection of net quantity, and there is also control on manufacturer as registered manufacturer means registration of packer, registration of importer. Really, these are the controls under the legal metrology. If we make a comparison between weight or measure, weighing and measuring instrument and package commodity, very identical. What? In relation to weight or measure, model approval and manufacturing license, verification, inspection, checking of marking, estimation of error, comparison of MP, exception, recommendation for repairing or rejection. This is the chain. When we are talking about the marking, very important line I would like to share. Sometimes we are very much careful in package commodity, but sometimes we ignore the marking. This is the first wrong step prior to verification. If you see the recommendation or our general rule, you will find the same language whatever is given in PC rule and whatever is given under the weighing or measuring instrument. What? The instrument shall bear thereon following markings. In package commodity, it is written, package shall bear thereon. That means prior to verification, prior to model approval, we have to see the marking. Marking confirms whether the weight or measure, weighing or measuring instrument is standard or not. Just like declaration on package commodity confirms whether it meets the regulation of PC rule or not. Regulation under PC rule, rule 4. Similarly, the marking. So very similar, checking of declaration equivalent to the marking. Estimation of error in net quantity means estimation of error in result. Comparing with MP in both places, same. In PC rule, we are saying decision to allow or not allow the lot. Similarly, in weight or measure, whether it is accepted for stamping or not. So very similar metrological control on both wings, whether weight or measure, whether package commodity. Now, non-automatic, this is also one of the example of the metrological control. Here we see under this presentation, metrological control on weighing instrument. 1 minute on weighing instrument, I would like to share how it is controlled in India. Manufacturer of weight or measure submit the application for getting the model approval to the Director Legal Metrology along with model and other required documents. After receiving the application along with the prescribed fees, model and documents, Director Legal Metrology send the model to the recognized laboratory like RRSL for testing. After testing, report is sent to the Director Legal Metrology with findings by the concerned laboratory. Based on the findings, if Director Legal Metrology is satisfied that the model approval certificate may be issued, then recommend to the central government, and central government issue the model approval certificate. And then manufacturer applies for manufacturing license to the concerned state or UTs along with the model approval certificate. And after getting the license, starts the manufacturing to conduct the business. Then further metrological control before selling the weight or measure, initial verification is done by the legal metrology officer of state or UTs. And after putting the weight or measure into use, the re-verification and inspection is done by the state LMO or UT. This is the control on the weighing instrument, whether it is non-automatic or it is automatic or it is measuring instrument where their model approval is required. Now, authorities responsible for regulation. In India, if we see, Government of India, Ministry of Consumer Affairs, Food and Public Distribution, Department of Consumer Affairs, Legal Metrology Division, and if you see, rules and regulations are framed by the central government. There is also a provision of training in legal metrology at ILM, standards at country level maintained at BIS, regional reference standard laboratories for the testing of the model approval and others, enforcement on legal metrology by state and UTs, primary standards maintained at NPL. This is a brief structure of the legal metrology at India. Now, just my presentation is started for non-automatic directly. Non-automatic weighing instrument, if we see, it works on the principle of action of gravity. Means where there is no gravity, this instrument will not work. It measures the mass of the load by action of gravity, whether automatic or non-automatic. If we see, non-automatic weighing instruments are classified in 5 categories. First one, graduated. Graduated means without auxiliary or with auxiliary. If without auxiliary, then verification scale interval is equal to actual scale interval D. with auxiliary, then verification scale interval is chosen by the manufacturer as per the requirements. Next one is non-graduated. Instrument not fitted with scale numbered in units of mass. That one is non-graduated. Next one is self-indicating non-automatic. Instrument in which position of equilibrium is obtained without the intervention of an operator. Self-indicating. Next one is semi-self-indicating. Instrument with a self-indicating weighing range in which the operator intervention after the limit of this range is required. Now, non-self-indicating, where the operator is required, means mostly mechanical based. So 5 types of the non-automatic weighing instruments. Generally, we have a image that we see the electronic, means digital based, non-automatic, but all 5 comes under the non-automatic weighing instruments as per our OIMLR 76 as well as per Legal Metrology General Rule 2011. Now, prior to coming on the testing part, few things we should know. Self-service instrument. What is self-service? Means intended to be operated by the customer. No one is there, just I purchase and I am operating. Self-service. Nowadays, there is a good scope of the mobile instrument. Non-automatic weighing instrument mounted on or incorporated. 2 words are there. Mounted means complete non-automatic weighing instrument is mounted on a vehicle. And incorporated means some parts of the vehicle is also used as a part of the non-automatic. Like mounted instrument, postal scale, mobile post office, and incorporated garbage wares, patient lifters, pilot lifters, fork lifters, wheelchair wares, like that. So incorporated means some part of the vehicle and works as the part of the non-automatic. So basically mobile instruments are of 2 types. One is mounted on vehicle and another is incorporated. Next one is very important, portable instrument. Nowadays in a digital field, portable instruments really helps to measure the vehicle mass. It can be carried from one place to another. So it has the load receptor in one or several parts, which is used to determine the mass of road vehicles and designed in such a way which can move from one location to another, like portable beverage, group of associated non-automatic axles, load wares. Sometimes when we are going to test and we are not knowing the individual electronic components or modules, then sometimes we see that what test we have to perform, what things we have to check. So prior to that, if you see, 2 words are very frequently used. One is zero setting device and tear device, very common. Zero setting device means when there is no load on the load receptor. For example, no load on load receptor. That device set the indication to 0. And tear device, the same work, but when the load is on the load receptor. When load is on the load receptor and set the 0 indication, means tear. And when there is no load and set the 0 indication, means zero setting device. Both are maybe non-automatic, maybe semi-automatic, and maybe automatic, whether zero setting device or tear device. Other words, very similar, initial zero setting device. By words, it is clear, obvious. Device setting the indication to 0 automatically when the instrument is switched on before it is ready for use. Prior to use, we just switch on. Sometimes we see that the indication is not 0. if that device is not working properly. So prior to use, when we switch on, then it must be set at 0 indication. Similarly, 0 tracking device, from word it is clear. Tracking means tracking what? Payment. Maintaining the 0 indication within certain limits of payment automatically. Very few words. Tear balancing device, without indication of the tear value when the instrument is loaded. For example, you have given the load on load acceptor, then tear will not come on the indication. While tear weighing device, that stores the tear value and capable at the end of the payment to give the display or printing. Next one is preset tear device. Subtracting preset tear value from gross or net weight. Very important. Whatever the gross weight or whatever the net weight of the commodity, subtract by the preset tear device. One is locking device. When we are using this device, it makes immobilizing all parts of the mechanism of instrument. Auxiliary verification device, device permitting separate verification of one or more main devices of an instrument. These are few terminology that will be used during the testing process. We should also know, because it is a weighing instrument, definitely it has a maximum capacity, minimum capacity. Why minimum? Because these are used for the trade purpose. They have no accuracy starting from 0. So the weighing range is set minimum to maximum based on the weighing range of the load cell. You see now number of balances, laboratory balances like ultra micro balance, analytical balance, micro balance, they have no minimum capacity. Even though in 4th schedule, Legal Metrology General Rule 2011, our digital type and working type, digital type, secondary standard and working standard balances also have no minimum capacity, because they are capable to maintain the accuracy starting from 0 to maximum. But here, minimum capacity, self-indication capacity, weighing range, all and scale divisions, maximum safe load. Beyond that load, if we will place, then it may destroy or may permanent deformation. So all those things is associated with non-automatic weighing instrument. Very important thing, sometimes we have the confusion about the E value and D value. Very easy. Actual scale interval means two categories are there. One is analog based instrument and another is electronic, means digital. If it is analog, then it is the difference between the values corresponding to two consecutive scale marks. Like our watch, second needle goes from one to another and another, then the difference between that points is 1 second. That 1 second is the actual scale interval of our watch. And if it is a digital type, then this is a difference between two consecutive indicated values. For example, D value is 2 gram. For example, in any weighing instrument, if D value is 2 gram, then 4, 6, 8, like that. So if we see this figure, for example, any weighing instrument, non-automatic, maximum capacity is 20 kg, minimum is 20 gram. Then how many number of verification scale interval? Number of verification scale interval in a very general way means we are going to divide the range of the capacity. It depends. If we would like to divide the range of capacity in 50 equal parts, means E value, means N value 50. If we would like to divide the entire weighing range in 1000 parts, that means that one is selected by the manufacturer E value, and that is the, if you see, for example, maximum capacity is 20 kg and minimum is 20 gram, N value is 2000. So 2000 number of verification scale interval, and value of one division is E value. If that is further divided, if you see here, blue arrow, this is E value, and it is further divided, means this is the D value, just like in vernier caliper. So always E value is greater than D value, less than or equal to 10 times of the D value. So number of verification scale interval, not only non-automatic, we are also calculating in automatic railway bridge, we are also calculating in catch weighing instrument, we are also calculating in others too. So basic concept, the maximum capacity is divided by the verification scale interval or actual scale interval, as the case may be. But you may think in automatic railway bridge, when we are going to calculate N value, there is no maximum capacity. There is maximum wagon weight divided by D. Why? You may think over that, because if partial weighing, then it is not going to weigh a wagon at a time. For example, maximum capacity is 50 ton and 2 axle wagon. Then maximum wagon weight may be 100 ton. Because of that reason, we are getting the indication in terms of not axle wise, but in terms of wagon wise. Because of that reason, in that place, maximum wagon weight. But here in non-automatic, maximum capacity. We are also familiar that non-automatic weighing instrument may be a single interval instrument, single interval, maybe multi-interval and multi-range. In multi-interval, what happens? One weighing range is divided into partial weighing ranges. Weighing range is one, but it divided into partial weighing ranges, and every weighing range has different scale interval. For example, maximum capacity is 10 kg, 20 kg, 30 kg. Verification scale interval, for example, 1 to 5. So for different partial range, different scale interval. While in multi-range instrument, it has two or more than two weighing ranges with different maximum capacity. In multi-interval, single maximum capacity and minimum capacity. But in multi-range instrument, different maximum capacity and different scale interval. We are also knowing this term is used during the compatibility check, reduction ratio. What is a reduction ratio? Because just we should not know only, okay, non-automatic weighing instrument, we have to perform 4 tests, eccentricity, repeatability, and discrimination like that. We should know when I will start the testing procedure, then you will be first time, I think, will be know that how many things are linked with each other. Reduction ratio is saying ratio of force acting on the load measuring device and force acting on the load receptor. Force acting on the load measuring device. If you go through this word, very important. What is the difference between that? Because we are knowing load receptor. When we place the load on load receptor, then how much stress on load receptor is FL, and how much stress goes to the strain gauge in load cell. That is the load measuring device. That ratio is called the reduction ratio. Very important word is their family in measuring instrument as well as in weighing instrument. For the metrological control purpose, this is very important. For example, any manufacturer of non-automatic weighing instrument, manufacturing of different maximum capacity, different E value, but the principle is same. Software is same. Then all comes under the family. Having same principle, common modules, only the ranges are changed. Then no need to take the model approval certificate for individual. He will get the model approval certificate for the family of that instrument. Now, we know that under the requirements of the non-automatic, it started from the accuracy class. Non-automatic broadly classified into 4 accuracy classes: special, high, medium, and ordinary. You see the symbol. These symbols are there. It has some meaning. Ovals of any shape or 2 horizontal lines joined by 2 half circles are permitted. When we are going to make a symbol, not like that, any just a circle, there is a condition. Ovals of any shape or 2 horizontal lines joined by 2 half circles is permitted. A circle shall not be used. If you make a complete circle, it is wrong. Circle shall not be used because why? In conformity with OIML R34, accuracy classes of measuring instrument is given. So that symbols becomes common. So in non-automatic, we should not use the circle for the accuracy purpose. Now, when we are talking about the graduated or non-graduated, about the E value or D value, so this table should be very much clear. Graduated without auxiliary scale means graduations are there, but there is no auxiliary scale. Just like you see a simple way, a scale, you have a scale for a normal use. This is only graduated, but there is no auxiliary scale. But in vernier calipers, there is a main scale and there is also auxiliary scale. Like that, there is also a concept graduated but not auxiliary scale. In under this case, E is equal to D means verification scale interval is equal to actual scale interval. But graduated with auxiliary indicating device, it is graduated, but auxiliary indicating device is there, then verification scale interval E shall be chosen by the manufacturer according to the requirements. E is greater than D, less than or equal to 10D, where E is equal to 10 की power K. K may be positive, negative, or whole number. Non-graduated, further E is chosen by the manufacturer as per the requirements of the non-automatic. Now, in all weighing instruments, there is a concept. What concept? A relation between accuracy class, verification scale interval, or actual scale interval, and number of verification scale. Everywhere, this is there. Heading is same. Special class, E value is given, their limit is given, and how you have to calculate N value, maximum by E. For special class, it is minimum is given 50,000 and there is no upper limit. Corresponding to that, minimum capacity is given in terms of the E. With the help of this table, we can check the conformity of the accuracy class of non-automatic. Generally, whatever the non-automatic weighing instruments are used for trade purpose, it is very difficult to test if the verification scale interval is less than 1 mg. Why? Because till date, in legal metrology, for measurement purpose, we have no weight less than 1 mg right now. So due to the uncertainty of the test load, so it is avoided, and if E is less than 1 mg, then for the trade purpose, we consider E is equal to 1 mg. For the instrument of class 1, if D value is less than 0.1 mg, not E, D value, then N may be less than 50,000. Means whatever is given in the table, not less than 50,000 as per this table, you see, then in case of, if the D value is less than 0.1 mg, then it may be less than 50,000. Now you may see the requirements of the multi-interval simply because the different verification scale intervals are there. So the concept is given E1, E2, E3 corresponding to the maximum capacity M1, M2, M3. And we have to cross check, and during the cross check of the multi-interval instrument, we should also see the table 17 as well as table 18. Okay, max divided by EI plus 1 for class 1 greater than or equal to 50,000, class 2 greater than or equal to 5,000, for class 3 greater than or equal to 500, and similarly for class 4 more than 50. If it meets the requirement of this table, then we can say that multi-interval instrument is okay accuracy wise. Now verification scale interval, as I have already discussed, this is the relation, and we can drive the values of E and D keeping in mind the relation E greater than D less than or equal to 10D. If you see E is equal to 1 gram, D 0.1 gram, and from this table you may see that it meets the requirement of the above relation. Similarly, D is less than 1 mg, and in every weighing or measuring instrument, there is the key point is the maximum permissible error. Because if we are not knowing the MP, we can't compare our result. We can't reach to the decision whether the test is fail or pass. So MP provision is there based on accuracy class, and on different loads, there is a range. And by using this table, one can calculate the maximum permissible error on a load for that instrument. Now, instrument also has the module like indicator, analog digital processing device, terminals, digital display, and weighing module. These modules may be separately tested, and if these modules are already tested from the laboratory OIML certified, like in India, we have also got the OIML certification, RRL Ahmedabad. So if any manufacturer has got the certification, for example, for indicator, for load cell separately, and the certificate is issued from that laboratory, then during the model approval in other countries, which is the member country of OIML, then no further needs of the testing of that modules. Now, just we are going to start the testing, and this time, whatever the remaining time, I will pass on the testing, and I would like to request all of you kindly pay the concentration to know the path of the testing. Actually, if we are knowing that these tests we have to do, then there is no difficulty if the process is given of the testing. Then by following that process we can do. But first we should know what we have to do. This presentation will help you how we have to start the testing. So first of all, metrological control. All the testings comes under the metrological control. When I'm talking metrological control, then from zero, from beginning I'm going to start. First of all, liability to metrological control. Liability to metrological control. First thing, what is liability? Let us see. That liability, we have to perform the test of the model approval, verification, whether initial or subsequent or service. But we should keep in mind, these items doesn't require the model approval. But simple equal arm beam, simple 1/10 ratio beam, sliding poise instruments, roller wall, and Brenger type counter machine, instrument with ratio platforms, load measuring device, sliders, poises, steel yard. These devices doesn't require the model approval. Next one is, if you see two words are there, type approval and type evaluation. What is the difference between type approval and type evaluation? These are the parts of the metrological control. 5 parts are there. First one is liability to metrological control. Second one is type approval. Third one is type evaluation. Fourth one is initial verification. And fifth one is subsequent metrological control. Only 5 things are there. Means if anyone discuss about the non-automatic, then you may say under the metrological control, total 5 things: liability, type approval, type evaluation, initial verification, and subsequent. Now, what is under the type approval? Very simple. Application for type approval. The application will be submitted to the approving authority. One instrument representative of the family. Modular approach. And applicant shall provide the information regarding metrological characteristics. Descriptive marking. What is a maximum capacity? You see metrological characteristics like that. Maximum, minimum capacity, self-indicating or not, weighing range, tear, safe load, scale division, number of verification scale interval, reduction ratio, type, family, everything must be there along with the application. This comes under the type approval. Now, then you may think, what is type evaluation? This is the core part. Under the type evaluation, examination of submitted document. That one is done. Whatever the document is submitted, that will be examined. Suitable checks of performance and type evaluation test and examination. These testings are the testings related to the model approval certificate made by the recognized laboratory. Under type evaluation, what thing? First one is complete instrument. That will be examined, complete instrument. After that, modules. After that, peripheral devices. After that, testing of a family of instrument or modules. 4 things are there. Means type or model approval testing, 4 things: complete instrument, modules, peripheral device, and family. When we are talking about the complete measuring instrument, under the complete measuring instruments, what things are there? Compliance of maximum permissible error. Whatever the test we will perform, every test comes under the purview of the MP. Permissible difference between the results. Discrimination. Variation due to influence quantity and time. Zero setting and zero tracking device. Tail devices. Functional requirements. Performance and span stability test. Technical requirements for non-self-indicating. Endurance test. Software controlled instrument. This is a complete instrument. So you see, under the complete instrument, in complete instrument, there is a applicability of the MP, discrimination, variation due to influence quantity, zero setting. For example, just only you see, and when you go, any of them, say discrimination, I am going, you see, under discrimination, we have to perform the test, whether it is analog or it is digital. Just extra load equivalent to 0.4 times of the absolute value, maximum permissible error for applied load, not less than 1 mg. All those conditions are given. So, first of all, we have seen complete instrument. After that, modules. Where modules are examined separately in the process of type approval, then 4 things we have to see, especially for modules. One is apportioning of errors. What is apportioning of errors? For example, non-automatic weighing instrument. It is fitted or it is equipped with load cell. It is equipped with indicator. It is equipped with weighing module. So every component contributes error. Every component contributes error. If load cell is there, then apportioning error of load cell. If indicator is there, apportioning error of indicator. But the square sum of all apportioning errors less than or equal to 1. So if we see under the modules, so apportioning of errors, we can see the fraction shall satisfy this equation: P1 square plus P2 square plus P3 square plus dash dash, depending upon the number of modules, less than or equal to 1. If it is purely digital device, module is purely digital device, then apportioning error equal to 0. For weighing module, it is equal to 1. And for other modules, it shall not exceed 0.8 and not less than 0.3. Means you can say apportioning error limit is what? 0.3 to 0.8. 0.3 to 0.8. And sum of squares of all apportioning errors less than or equal to 1. Let us see one example to clarify the apportioning error. Please see. For example, indicating element is there, and no value for the indicating element is given by the manufacturer. Then it will be taken 0.7. It will lie between 0.3 less than or equal to 0.7 or 0.8. Similarly, for load cell, if load cell is there, no value of the load cell is indicated in the OML or NTEP certificate, then it will be taken 0.5. Connecting elements, we know that some leads are required to connect or to interface the device from one to another. Then if its value is taken 0.5, so how many values becomes here? As example, indicating, load cell and connecting. So what is the overall apportioning errors? We see apportioning factor for, if we see regarding the load cell and regarding the connection, 0.5 and 0.5 whole square, 0.5. Similarly for indicator, 0.7 square, 0.49. Total is 0.5 plus 0.49, 0.99. This is less than equal to 1. Means it meets the requirements of the apportioning factor. Now, what tests are applicable on that? Separately, these tests are given under the annexure C, D, and E. Especially annexure C and D. D meant for digital data processing, and annexure C is meant for analog data processing, and annexure E is for weighing modules, and annexure F for compatibility, and annexure G for the software control. So if we see compatibility of that modules, whether that load cell should be fitted or not on that non-automatic, whether that indicator is suitable for that non-automatic or not, we can see. For example, this is weighing instrument. Accuracy class is given 3. Maximum capacity is given 60 ton. Verification scale is also given. Then indicator must also be of accuracy class 3. And load cell, we know that load cell having 4 accuracy classes, A, B, C, D. So if accuracy class 3, then load cell accuracy class should be C. And it may also D if it meets the requirement. But C is suitable accuracy class. So we can see at a glance, this is as per the annexure F, compatibility of the modules. Accuracy class, first of all, we have to check accuracy class. Load cell C, indication 3. This should be equal to or better accuracy class 3. So our weighing instrument, WI weighing instrument, accuracy class 3, that means it meets the requirement of accuracy class. Similarly, temperature range, we know that for non-automatic -10 degrees centigrade to 40 degrees centigrade. Load cell -10 minimum and maximum 40. Indicator also meets the requirement as per the requirements of the weighing instrument. Next one is apportioning factor, means for indicator, for load cell and for connection, 0.25, 0.25, 0.49, and total is less than or equal to 1. This also meets the requirement. In whether the modules are compatible with that instrument or not. Similarly, under the type evaluation, we have to check peripheral devices and testing of the family of instrument or modules, and what standards we have to use, whether for complete instrument, whether for modules, whether for peripheral device, whether for family. The same test standards are there. These test standards, as per the OIML or as per our rule, is what? Verification of an instrument that meets the requirement of OIML Article 1 for the international purpose, and for as per the nation-wise, we have our standard Indian weights, namely reference, secondary, working, and standard weights are measures. So accuracy wise is what special thing is there? That standard error greater than 1/3 of the maximum permissible error of the instrument, means shall not have the greater than that. Means we can say our standard must be 3 times accurate than the instrument under verification. Such weight we can use for the verification purpose. For example, you are going to verify non-automatic by using working standard weight. So if for 100 gram load, non-automatic weighing instrument has 5 mg error, so our 100 gram working standard weight minimum has the accuracy 5/3, then it can be used, means 3 times accurate than that. Now, when we are talking about these provisions, so testing applicable for pattern evaluation, we can see what test we have to perform. Annexure A, total annexures are there. If you see, 8 annexures are there. Annexure A, B, C, D, E, F. 7 annexures are there. Very simple. In annexure A, only testing procedure of non-automatic is given. While under annexure B, additional test for electronic instrument. That annexure B is common up to a certain extent to all weighing instrument, whether automatic or non-automatic. Because when we are saying electronic instrument, there is a supply provision, say 5 volt. Definitely there must be variation. There must be some influence due to the variation in voltage, due to the variation in supply. That means these are the influence quantity. So these tests prescribed under annexure B are almost applicable. All the weighing instruments, those are electronically equipped. So let us see an X-ray testing procedure. Now this is the last phase of the presentation and very important how we have to start the testing. Stepwise testing. Step 1. Now the application is received at the competent authority for model approval. Then how it will be started? Step 1 is saying administrative examination. On received application, we have to do administrative examination. Under administrative examination, what things are there? Review the document submitted, including photographs, drawings, relevant technical specification. We have to determine at that time education, operating manual, that all those things be reviewed under the administrative examination. Next step is compare construction with document. Whatever is written on document, whether the instrument is constructed as per that or not. So second step will be compare construction with the document. What things we have to compare? Let us see. Examine the various devices for ensuring the compliance with the documentation. We have to check whether it complies the accuracy class, whether it complies the verification scale interval like this. The accuracy classes must be there as per this provision. Scale interval, verification scale interval must be as per this requirement. All those things will be checked during the confirmation of the constructional detail. Step 3 is a initial examination. Now from here it is started. Initial examination. Under initial examination, how many things? From this presentation, you may know, if anyone talk, okay, we have to do initial examination. What things come under the initial examination? Only 3 things, not more than that. What things? Metrological characteristics under initial examination. Descriptive marking under initial examination. Stamping and securing. Whether the provision of sealing or to receive the stamp on instrument is there or not. Descriptive marking about the instrument, it is there or not, just like in package commodity as I have already discussed. Now characteristics means maximum, minimum capacity, tear effect, D value, E value, whether it is multi-interval or multi-range, all those things are there or not. This is done under the initial examination prior to start of the main test. So under initial examination, you see metrological characteristics. All those things I have already discussed. These are the metrological characteristics. Descriptive marking. An instrument shall carry following markings. What? Manufacturer marks name written in full. Metrological markings, whether this is special accuracy class or high or medium. Verification scale interval. Compulsory, if applicable, what? Name or mark of manufacturer's agent for an imported instrument. If it is imported, then name and address. You also see, na, in package commodity rule 6 is started from where? Name and address of manufacturer. If manufacturer is not a packer, then name and address of manufacturer and packer. And in case of imported item, name and address of importer. The same thing is also there. If it is imported item, then name and address of the agent for an imported instrument. Serial number, all those things is checked during the initial verification. Now, third one is very important because under the enforcement, there should be a provision of stamping and securing the instrument means sealing provision must be there. So all those things are checked during the initial verification under step 3. So we have reached up to the step 3. Step 1, administrative examination. Step 2, constructional detail confirmation. And step 3, initial examination. When the instrument is passed under these 3 steps, then we will move for step 4. This is a very exhaustive and main and core part step of the non-automatic. Whatever we are talking about the non-automatic, only one word is quite enough to say. If anyone is talking, okay, we have performed the eccentricity test. Okay. If anyone is saying we have performed the discrimination test, you say, okay, any name of the test comes under the performance test. We are performing the test to check the performance of the instrument. That is step 4, performance test. Number of tests are there under the performance test. What? First one is general conditions. Second is checking of zero. Third, setting to zero before loading. Determination of weighing performance, accuracy test. Then discrimination test, eccentricity test, tear, sensitivity if it is a non-self-indicating, repeatability test, variation of indication with time for class 2, class 3 and class 4. Test for the stability of equilibrium and additional test for portable bay bridges. This much tests under the performance test. If you see this screen, under this single page presentation, this covers the entire performance test performed during the model approval, starting from the general condition. So just for example, because for details, if you have this idea, then step by step you may go and you may follow the paragraphs, whether of general rules or OIMLs, that helps you to know in details and helps in the testing process. But the process is same. Say general condition, because within 1.5 hours to discuss each is hard work because it is exhaustive. But I try to trace a path. First, performance test, general condition. What we have to see? Normal test. Under general condition, number of things are there. Normal test condition we have to check whether the suitability of.
Na kiran ka ne da rana. Na kiran ka ne da na kira ka sai
Participants are requested to kindly switch off your mics. All the participants are requested to kindly switch off your mics. And you can switch on your videos, please. Thank you. Oh, continue, sir, please.
Thank you, sir. Normal test condition we have to check. Temperature range, power supply section, what power supply provisions are given, reference positions, automatic zero setting, indication, adjustment, recovery, preloading, multi-range instruments, whatever the general conditions, as per that we have to check each and every one. Next one is checking of zero. Under checking of zero, we can see range of zero setting, zero indicating device, and accuracy of zero setting. See initial zero setting, with load receptor empty, set the instrument to the zero. Whatever in terminology I have discussed, all those things we have to check during that. Similarly, zero indicating device, because these provisions are there, your instrument may be fitted with the zero indicating, with the zero tracking, all those things. So regarding that metrological characteristics provision, the testing provisions are there. Now setting to zero, determination of weighing, for example, determination of weighing performance, you are going to check. Under that, in weighing performance, number of things are there. What things you will check under the weighing performance? Just we are knowing, okay, weighing performance, we have to test the instrument by applying 5 different loads covering minimum to maximum range. But weighing performance covers weighing test, supplementary weighing test, evaluation of error, testing of modules, weighing test using substitution material. Just we see weighing test, simply whatever we are doing, the first step, we have to take test loads from 0 up to including maximum. At least 5 test loads are required. The test load selected shall include maximum and minimum. Minimum only if minimum is more than 100 mg. If it is less than 100 mg, then no need to perform the test at minimum load. Next one, maximum permissible error where the change. Load cell at which maximum permissible error is changed, we have to select this. Then during initial verification and subsequent verification, this test is applicable. In model approval time and during verification, that test is applicable. This is the performa as per the OIML. This is the table, and with the help of this format, we can take the observation in increasing order as well as decreasing order. And finally, we have to calculate corrected error, and that will be compared with the maximum permissible error. Next one is supplementary weighing test. What is supplementary weighing test under this? The instrument with an initial zero setting device with a range greater than 20% of max. Supplementary weighing test shall be performed using the upper limit of range at 0 point. This is the main difference. Upper limit of range as a 0 point. Evaluation of error. For evaluation of error, formula is given prior to rounding. P is equal to, you know that, I plus half E minus delta L, and error prior to rounding, E is equal to P minus L. This formula is used to calculate the error, whether we are going to calculate initial error or error on load by applying the requisite table. Testing of modules, this is also under that. When we are testing the modules separately, then we have to see, as I have discussed, 4 things are there. Proportioning error, and here we can see one thing very important. Indication with a scale interval is smaller than 1/5 times of apportioning error into E, or by evaluating the changeover point of the indication with the uncertainty better than 1/5 times of the proportioning error during the testing of the modules separately. Weighing test using substitution material. This is also performed. The test shall be carried out during verification at a place of using, taking a weighing test into account. In this test, we have to apply the loads from 0 up to and including the maximum quantity of standard weights, and we have to determine the error. In case of instrument zero tracking device, the indication say 10E is reached. So under the performance test, similarly, discrimination test is also there, repeatability test. For discrimination, we can divide into 2 parts. One is non-self-indicating and analog, and another is distal. So when we are going to perform the discrimination test, for example, it is not electronic based like this self-indicating, then what is the provision? We have to place not less than 1 mg on a load receptor very gently. For certain extra load, the equilibrium mechanism shall assume a different position of equilibrium as specified. Means if we put a small load gently on the load receptor, then the equilibrium mechanism shall get the different position. You may see this is the observation table for discrimination test if it is analog type. In digital indication, we can see during the type examination, instrument with D value greater than or equal to 5 mg. A load plus sufficient additional weight 10 times means in terms of the 1/10D, we have to place on the load receptor. Then we have to remove successfully until the indication I decrease unambiguously by 1 actual scale interval. Then we have to add equal to 1.4D. Then gently we have to place 1E means total 1.5E. Then we have to get the indication I plus D. D means actual scale interval. Like this. We can see example of discrimination for any non-automatic weighing instrument. Just like as example, we can perform, first of all, we have to check accuracy, then MPE. After that, from the table, you see like that. Discrimination test at minimum load plus 1E. Indication, for example, 210 gram. Remove the load. 1/10E we have to add, said 1 gram, then 1.4E, and then indication I2, 220 gram. So if we see I2 minus I1, then it is 10 gram. Similarly, at half load and near to full load, we have to perform the discrimination test. So under performance test, repeatability test is there, variation indication, all those things we have to do. Now, next one is step 5, influence factors. After performance test, actually in enforcement, for the re-verification or subsequent verification or inspection, only up to the performance test, influence factor tests are exempted for the re-verification or inspection, because these tests are totally laboratory based. Few of them, only tilting under the influence factors, this can consider during the initial verification and subsequent. So under influencement factor, tilting class 2, class 3 and class 4, not for class 1. Warm-up time test, temperature test, voltage variation and endurance test. These are the influence factors. If you see any one of them, say voltage variation, under the voltage variation, we have to see what kinds of the variation may be there. Variation of AC mains voltage, we know that fluctuations. Variation of external or plug-in power, supply device, power supply, variation of non-rechargeable battery. All those things come under the voltage variation test. If you see endurance test, this is applicable only the instrument class 2, class 3 or class 4, with maximum less than 100 kg. More than that, then this test is not applicable. So as per the provision, we can do the indoor test also. When we are talking about the Annexer B, so there is a test regarding the general requirement for electronic instrument, damp heat steady state, performance test for disturbance, and span stability test. 4 tests are there basically. Under the additional test for electronic instruments, 4 tests are there. General requirements, damp heat study, performance, and span. But when further we come on performance test of disturbance, then there is AC mains, whatever we have seen in influence factors, the same thing is there. AC mains, thrust, surge, electronic discharge, immunity related electromagnetic field, immunity to conducted radio frequency, special EMC. These things are covered under the additional test for electronic instrument. So you see, first damp heat, performance, and span stability. So all tests are there under Annexer B. Before, if we see span stability, you may follow this testing procedure. Is given, not applicable for class 1 machine, and we have to see that whether a long period of time, how much it is stable under that test. Test duration, everything is given 28 days, 5 hours, not less than 16 hours. All terms condition we have to follow as per the OIML, and we can do this test. Similarly, Annexer C, especially this is not mandatory. It is mandatory when the modules are tested separately. Otherwise, only Annexer A and Annexer B. If broadly classified, Annexer A deals the testing procedure, especially performance, and Annexer B broadly deals the additional test for electronic instruments like influence factor test, like disturbance, like span stability test. And other tests are related to the modules. Because modules are basically 4 types. One is analog, another is digital, and weighing module. So based on that modules, their separate tests are given under the Annexer C, D, E, F, and G is especially for software. So these annexers may kindly be followed for the testing. With these few words, I would like to finish my presentation. Just simply a layout about the details of the testing procedure of non-automatic, and whatever the steps I have given, if these steps are followed and details references are taken from the rule, our rules are OIML, then very easily, without any confusion, then after what test we have to go for next, this presentation undoubtedly, I hope that it will help you. Thank you.
Thank you very much, sir, for your brief and very good presentation. Now, I think that the participants can understand how to do the verification, stamping, calibration of weighing and measuring instruments. Thank you very much. I hope that we do not have good questions here. So thank you very much, sir. Thank you. I would like to request you to share this presentation to me so that we can put it on the website, as well as this whole video will also be shared on the YouTube channel and the website, so the participants can see at any point of time wherever they wish to see. With this, I would like to request the our LIC team and